Hello, my name is Sylvie Trudel from the Cosmic Group, and today we will cover Module 3, MIS Case Study Overview. The information provided in this module are taken from the different case studies available on the Cosmic website. In this module, you will learn the business case studies with a slight overview of them. And there are topics in other module as well if you haven't viewed them already. Module 1, why and when measure functional size. Module 2, cosmic key concept and definition. Module 4, real-time software case study overview. Module 5, cosmic non-functional requirement. Module 6, early sizing overview. And Module 7, the estimation process. Now, the cosmic manual comes in several parts. The part 1 is the principles, definition, and rules. Part 2 are the guidelines to implement those principle, definition, and rules. And part 3 are examples of cosmic concept and measurement, consisting of part 3A, standard measurement strategy examples, part 3B, real-time examples, and part 3C, MIS examples. Now, this presentation, Module 3, is about the Management Information System business examples. Let's look at a standard strategy for whole online business application. The functional user requirements of any online business application define the functionality needed by the business, including the human interface requirement for the customer of the software. The FIR do not describe functions provided by the operating environment or by control commands. So in this case here, the online business app that we want to measure, it has human users as users, entry data movement and exit data movement, where the human user interacts with the application. There could be interaction also with other application. Well, if I send a request to this other app, it's an exit, or if I receive the data or a request from these other apps, that will be an entry. And of course, with persistent storage, there are read and write. Now, if we look at an online business application that has been divided into major components, the following context diagram for an online business application that is developed using a multi-layer or multi-tier architecture with the common 3 major components, which are user interface, right here, the business rules, and the data services, or often called the data access layer. They could be developed with different programming language, and they could be deployed on different servers. And at this end, there's the human user, and this other end, also other interfacing application. Now, there are 2 more boundaries compared to the previous page in between those 3 major components, which coincide with the interfaces between those 3 layers. So that means that the business rule layer is a functional user of the interface user, and also it's a functional user of the data service. And the user interface has 2 functional users, the human user and the business rule, and so on for the data service. If we look at a business application that is processed in batch mode, you know, those batches that execute automatically during the night, well, any human user of a batch process do not interact directly with the software. However, Human users provide the input data for the functional process of the application and receive the output data from the batch processing. So human users or other upstream interfacing application can trigger with an entry the batch functional process that can request data from other downstream interfacing application, which will provide this data. The batch will execute, writing some data, reading other data from its persistent storage, and then it could display or send information to the upstream interfacing application. Now, if we look at an example of a MIS, Management Information System, let's say we have a firm that might specify separate functional processes to update the data of a person. Let's say it's a human resources functionality for each of the possible transitions that needs to be done between the status of being single, married, widowed, and divorced. We want to add a status, modify a status, delete a status, or simply query the different employee status. And each action is a different need for the user. If we take an example of an inquiry on a human resource database, suppose a requirement for an inquiry is to display a list of employee names selected from a file of employee data with any combination of the three input parameters, age, gender, and education level. Well, those three parameters must also be output. And if no employees meet the selection criteria, an error message must be displayed. In that case, if we look at the number of data movement, we've got 5 data movement for this functional process. Well, first, age, gender, code, education level. Those are the attributes of the data group called employee selection parameters. That's an entry. Later on, we will see the same data group is also an exit because it needs to be output. There's the employee data that must be read. Based on those selection parameters, we will read employee data. We will exit from employee data the employee name and also exit an error or confirmation message. If we take a multi-item order example, the first specifies a functional process that enables the entry of a multi-item order into a database, which already has persistent data about clients and products with the following attributes. There's first an order header with order ID, client order reference, required delivery date, etc. And then a list of order items that contains an item ID, a product ID, the quantity ordered, maybe unit price, maybe discount per item, if it's taxable or not, etc. So the key attributes order ID and item ID are generated automatically by the software. And the client ID and the product ID must be validated on ID. Well, they must exist, of course. The entered data must be validated and confirmed, or an error message is displayed. In such a case, the smallest possible size would be 7 cosmic function point. That is, triggering entry is the order data. That's the header of the order. And then we must read the client data with client ID. We will then enter the order items with the product ID, quantity ordered, etc. So we must read product data with that product ID. And then once it's completed, will be writing, so there's a write data movement for order data and order item data, two writes, because those are two different data groups. And at the end, there could be also confirmation or error message, that's an exit. So this is a super simple multi-item order functional process. As I said earlier, it's usually in reality bigger than that. So batch processing now. The batch stream for an order processing system might contain functional processes to add new clients, add new and delete obsolete products, enter new orders, enter order cancellations, etc. So each of these different functional processes should be analyzed end-to-end and independently of any other functional process in the same stream. Each functional process is triggered by its own triggering entry and should be analyzed as if the data, including other possible non-triggering entries needed by the functional process, were being entered online by the human functional user. For processing the employee data, assuming a create functional process, we'll have the entry is the employee data, we write the employee data, and then we exit a confirmation or error message. However, if you first specify in a batch process that instead of displaying something on a monitor screen, we prefer to log the execution in a log file that can be consulted later on, then the error or confirmation message will be a write data movement. So when sizing an application that requires data to be entered via one or more batch interface files, all using the utility, well, the utility functional process should be counted once for the application. That's if it is within the measurement scope. If you're reusing something that already exists and it's not really part of the measurement scope, let's say because you don't have to develop it, it's not part of your project, therefore you're not measuring it. If we look at batch processing with a temporary storage, suppose that order processing functional process, which is being measured, and the employees who are using this order processing, well, it's possible that within its implementation, temporary storage could be required before finalizing the permanent storage of the data for, let's say, sorting some data or combining several files into a single one. But if what we call temporary storage is, let's say, a file in a database which content will only last for the time during which the functional process executes, because it will be destroyed at the end. So in that case, we're not counting that temporary storage because it's not a data group. It's a way to implement the functionality mostly for performance purposes. So it cannot be considered in the measurement. We simply forget about the temporary storage. In conclusions, there are many other possibilities. So please refer to the Cosmic Measurement Manual for ISO 19761, Part 3C, Management Information System Examples at this address, cosmicsizing.org, publication, Measurement Manual, version 5-0, Part 3C, MIS Examples. Thank you.